So this short lesson is going to examine adding and subtracting fractions. Okay, so the first thing I want to do is give you an analogy. Let's take a look at this addition exercise right here. Notice that I have the item with a red underline, and then I have the number of that item that I have above the blue line. Okay? So I want you to add those two together, thinking about what would go above the blue and what would go above the red. I'll give you a second to think about that. Well, hopefully you said there actually is no answer, because it's not 5, because then we'd run into the problem of what would we put above the red. It's not 5 dogs, we still don't have a full 5 dogs, and it's not 5 cats either, so actually it's no answer. However, is there a way maybe we could change these categories and make them a little more general, not quite as specific, and then be able to add them? In other words, dogs and cats both fall under what category? There may be more than one answer. I'm just going to do one example. Think about that. Well, one thing I came up with is animals. We're not as specific, but but they are both animals, and if I change them to animals, 3 animals plus 2 animals, now we can add that and get 5 animals. Now fractions work in a similar manner. So put a fraction problem up here. Let's say I have 3/4 plus 2/5. In other words, can we add those together? No, because 4ths are kind of like dogs, and 5ths are just like cats, so the analogy holds in that we cannot add 4ths and 5ths, because what would we put right here? We have to change the 4ths and 5ths to something like animals, a category that they're both the same, and then we can go ahead and add them. Right? So let's look at a couple of examples. Take a little step back and look at a couple of examples of adding and subtracting fractions. In other words, we have to get something they have in common, and that's where the phrase common denominator comes from. Okay, let's just start off with a fraction where the denominators are the same, 7th and 7th. So this is kind of like saying they're already animals and animals. And how many of them do we have? Well, here we have 3, here we have 2, so 3/7 plus 2/7 equals 5/7. And so for subtraction, we also need common denominators. We just subtract the numerators in that case. So if I change this, 3/7 minus 2/7, that then becomes 1/7. Okay? Right, but what happens if they're not already in 7ths or already in 4ths or 10ths? Take a look at another example. Let's say we have 2/7 plus 3/14. So right now we have 7ths and 14ths, so we cannot add those together. We need to make them the same. So we need to adjust one or both of these fractions to get a common denominator, and preferably we're always going to look for the lowest common denominator. Well, one thing we can do is we can start listing the multiples. Remember, there are three ways we can list the multiples: do the factor tree method or do the ladder method. Well, let me just start listing the multiples. So the first three multiples of 7 are 7, 14, and 21. The first three multiples of 14 are 14, 28, and 42. What's the lowest one they have in common? 14. So in fact, when you get unlike denominators, the first thing you might want to check is, does the smallest number go into the largest number? Okay? That way, you'll only have to adjust the smaller number fraction, smaller number denominator. Okay, so we found out that 14 was the common denominator, lowest common denominator, so we don't have to change this, but we do have to change this. And remember, with equivalent fractions, if we change this by multiplying by 2, we have to do the same thing to the top to keep it equivalent. So now we have 4 over 14 plus 3 over 14 equals 7 over 14. Right? Now we can add them. And this could be reduced to 1/2. Okay? If we wanted to subtract, again, we do the same adjustment, make them both 14ths. This time, if we're subtracting, we do 4 minus 3 and get 1/14. Okay. Let's look at one more where we have to change both denominators. Let's look at 3/4 plus 1/10. So obviously right off the bat they are unlike, so we're going to need to adjust them and find equivalent fractions that have the same denominator, preferably the lowest one, or then we'll have to reduce. Okay. Does 4 go into 10? Nope. So maybe let's use the ladder method this time. I'm going to put 4 and 10 into the ladder. I'm going to list the first 5 prime numbers right here. And what we're looking for, remember, is a prime number that goes into both 4 and 10. Do you see one? Yes, 2. Put that off to the side and then divide. 4 divided by 2 is 2. 10 divided by 2 is 5. Okay. Now, is there a prime that goes into both 2 and 5? No. 2 goes into 2 but not 5, and 5 goes into 5 but not 2. So, our lowest common multiple is the product of what we took out by what's on the bottom rung. So 5 times 2 times 2. And our lowest common multiple is going to be 20. So that means we have to adjust both of these to 20ths. So we got to look for the number that we multiply 4 by to get 20. What is that number? 5. And then to keep it equivalent, if we multiply this by 5, we have to multiply this by 5 as well. What number multiplies by 10 to get up to 20? 2. And then do the same thing to the numerator. So our new fraction is our new fractions are 15 over 20 plus 2 over 20. Now they are the same category, so we can add them. And we get 17 over 20. And similarly, if this were a subtraction problem, We still would have needed to adjust them to 20ths, but now we go ahead and subtract, and 15 minus 2 is 13. So that is adding and subtracting fractions, and this concludes this video.